Welcome to my YouTube channel, Dhanesh here. Today I am going to discuss about one of the most important supervised machine learning algorithm, support vector machine, SVM. SVM is one of the most popular and widely used supervised machine learning algorithms. SVM offers very high accuracy compared to other classifiers such as logistic regression and decision trees. It's known for its kernel trick to handle non-linear input spaces. It's used in a variety of applications such as face detection, intrusion detection, classification of emails, news articles and web pages, and classification of genes and handwriting recognition. Now I am going to discuss about hyperplane. It is one of the important concepts when we discuss about support vector machine. Let's understand what's a hyperplane. Generally, support vector machines is considered to be a classification approach, but it can be employed in both types of classification and regression problems. It can easily handle multiple continuous and categorical variables. SVM constructs a hyperplane in multidimensional space to separate different classes. SVM generates optimal hyperplane in an iterative manner which is used to minimize an error. The core idea of SVM is to find a maximum marginal hyperplane MMH that best divides the dataset into classes. That's why an SVM classifier is also known as discriminative classifier.
See, now I am going to give some more clarity on hyperplane. See, we already discussed about hyperplane. So I am going to give you some more idea on what exactly is a hyperplane. A hyperplane is a decision plane which separates between a set of objects having different class memberships. If you see here in the figure, I have marked here. This is two types of data sets. Here you can see one is marked red in color and the other one in blue in color. You could see here we have come up with an, in the right hand side figure, we come up with an optimal hyperplane. You can see here that's the optimal hyperplane. In the left side you have multiple hyperplanes, but the optimal hyperplane we have seen in the right side. And you have the maximum margin. See, some of the data points in the in the margin, in the near to the optimal hyperplane, having the maximum margin as the width, that's shaded. You could see here the red points and the blue points, it's shaded there. Those data points we call it as the support vectors. See, support vectors are the data points which are close to the hyperplane. These points will define the separating line better by calculating margins. That is the maximum margin. It's shown in the figure. These points are more relevant to the construction of the classifier. If you want more clarity on this support vectors, see, it's marked here. Here we have shown the margin width, and you could see some data points which is coming in the margin width. We call it as the support vectors. Fine. Now I am talking about what is this margin. I am talking about the margin width. What exactly is margin? See, a margin is a gap between the two lines on the closest class points. This is calculated as the perpendicular distance from the line to support vectors or closest points. If the margin is larger in between the classes, then it is considered a good margin. A smaller margin is a bad margin. Now we are going to discuss about the working of SVM, how support vector machine is working. So that's what I am going to discuss now. The main objective is to segregate the given data set in the best possible way. The distance between the either nearest points is known as the margin, we already discussed. The objective is to select a hyperplane with the maximum possible margin between support vectors in the given data set. SVM searches for the maximum marginal hyperplane in the following steps. First step, if we discuss about when we talk about the first step, generate a hyperplane which segregate the classes in the best way. Left hand side figure, if you see the left hand side figure showing three hyperplanes, black, blue and orange. Here the blue and orange have higher classification error, but the black is separating the two classes correctly. The second step, select the right hyperplane with the maximum segregation from the either nearest data points as shown in the right hand side figure. So we have selected the black hyperplane. Next point you need to understand here is the nonlinear and inseparable planes. How do we deal with nonlinear and inseparable planes? See, when the data sets are scattered like as shown in the figure, how do we handle such situations? Some problem can't be solved using linear hyperplane. See, whatever we were discussing was linear hyperplane. See, as shown in the figure left hand side, the linear hyperplane on work. In such situation, SVM support vector machine uses a kernel trick to transform the input space to a higher dimensional space as shown on the right hand side. The data points are plotted on the x-axis and z-axis. Z is the squared sum of both x and y. Now you can easily segregate these points using linear separation. Now we will understand different SVM kernels. See, what is SVM kernels? The SVM algorithm is implemented in practice using a kernel. A kernel transforms an input data space into a required form. SVM uses a technique called the kernel trick. Here the kernel takes a low dimensional input space and transform it into a higher dimensional space. In other words, you can say that it converts non-separable problem to a separable problem by adding more dimension to it. It is most useful in non-linear separation problem. Kernel trick helps you to build a more accurate classifier. There are different types of kernels you can use. One is the linear kernel. See, a linear kernel is used when the data is linearly separable. That is, it can be separated using a straight line. It is one of the most common kernel to be used. It is mostly used when there are a large number of features in a particular data set. A linear kernel can be used as a normal dot product of any two given observations. The product between two vectors is the sum of the multiplication of each pair of input values. You may be aware of that. Next is the polynomial kernel. A polynomial kernel is a more generalized form of the linear kernel. The polynomial kernel can distinguish curved or nonlinear input space. Here in the equation, d is the degree of the polynomial. When d is equal to 1, it is similar to the linear transformation. The degree needs to be manually specified in the learning algorithm. Next, we need to understand radial based function kernel, that is RBF. See, the radial basis function kernel is a popular kernel function commonly used in support vector machine classifications. RBF can map an input space in infinite dimensional space. Here, gamma is a parameter which ranges from 0 to 1. A higher value of gamma will perfectly fit the training dataset, which causes overfitting. Gamma is equal to 0.1 is considered to be a good default value. The value of gamma needs to be manually specified in the learning algorithm. Next, we will discuss about SVM implementation. See, in the model of the building part, in the model building part, you can use the cancer data set, which is a very famous multi-class classification problem. The data set is computed from a digitized image of a fine needle aspirate FNA of a breast mass. They describe characteristics of the cell nuclei present in the image. The dataset comprises 30 features like mean radius, mean texture, mean perimeter, mean area, mean smoothness, mean compactness, etc., and a target, that is the type of cancer. Here, the data has two types of cancer classes, that is the malignant, that is harmful, and the benign, not harmful. Here you can build a model to classify the type of cancer. The dataset is available in the scikit-learn library, or you can also download it from the UCI machine learning library. So let's discuss about the implementation and the Python coding about scikit library. Here we are going to discuss about the implementation part of a support vector machine. So I'm using Google Colab. See, you may be familiar with this environment. Even in my previous videos, I have shown how to do it. See, this is the way you can run it. Go to runtime, you change runtime type, you will change it to GPU and save it, and it's connected. Here you need to connect. So that's all. So I have I'm using the sklearn. So from sklearn we import the data sets, and we have we are loading the data set. That's what I have done. I have the code with me. I will run some of the we will understand how our data sets behave. So I am going to show it here. See, I am running this piece of code here. So I am to get a new cell like Jupyter Notebook, you can get it, and even Jupyter Lab is also there. You can in the same way to run it. See, I am running it here. See, you can see the features here. It's all there. So I have mentioned in the the features. I have told you can see all those features here. Mean radius, mean texture, mean perimeter, mean area, all these things you can see here. Now what I'm going to do is I am printing these informations. I will copy this code, and so this is what I am going to print it. I am running it now. See, you could see I have printed the data shape, and I have printed the shape. So it is 569,30. You got it. Now we will print these information. We will try to print this. You will get more clarity on that. See, I have printed the cancer data features, top 5 records, and I have printed the cancer labels. You can see it here. You can see the labels and the features here. That's what we got now. Now I am going to get a new cell, and we will import, train and test split functions. So that's what I'm going to do here. You may be, if you are familiar with machine learning algorithms, you are familiar with these things. See, to understand the model performance, we need to split the data, right? You are familiar with that. So that's what we have done in this piece of code. To understand the model performance, dividing the data set into a training set and a test set is a good strategy. Split the data set by using the function. We are using the function train underscore test underscore split. You need to pass 3 parameters there: feature, target, and test underscore set size. Additionally, you can use random underscore state to perform records randomly. That's what we are doing here. Now we will, we have done that. We have splitted the data. Now what we will do is this thing, import. Here the SVM model we are importing, and we will train the model. That's what we are going to do. Just we will get into a new code, and we are trying to train the model, and I am running it. So we are importing SVM model, and we created a SVM classifier, and we are training the model using the training sets. See, to generate the model, first we build the support vector machine model. First we import the SVM model and create support vector classifier object by passing argument kernel as the linear kernel in SVC function. So different types of kernels we use. We are using the linear kernel. There is polynomial kernel. We discussed all those aspects. Then you have to fit your model on train set using fit, and perform prediction on the test set using the predict method. That's what we do. So now we are going to predict the predict method. We are going to use it. Let me see here. We have the predict method. This is the predict method we have. So we have done predict the response for test data set. That's what here we are doing it. After that, we need to evaluate the model. See, let's examine how accurately the classifier can predict the breast cancer of patients. Accuracy can be computed by comparing actual test set values and predicted values. That's what we do while we evaluate the model. You may be familiar with that. So let's do that now. For that, we are predicting the accuracy of our model. See, we got the accuracy as 0.9649. That's the accuracy we got. It's a good one. Now we will do the precision and recall. 2 parameters, we usually do. So that's also we are going to print. You can see here I'm going to get the precision and recall of our machine learning model. Let me run this. It's printing precision. We are getting 0.98 and recall 96. It's really good. So this is the implementation part. Now let me talk about some more aspects related to this SVM implementation using scikit-learn we have done. Next I am talking about tuning the hyperparameters. See, you may be familiar with hyperparameters. In machine learning, you need to understand hyperparameters means you have the hyperparameters here. You need to understand hyperparameters in machine learning. A hyperparameter is a parameter whose value is used to control the learning process. That's a hyperparameter. Here we need to understand the kernel, regularization and gamma are the parameters we need to correct for tuning our machine learning model. The main function of the kernel is to transform the given data set input data into the required form. There are various types of functions such as linear, polynomial and radial basis function we already discussed. Polynomial and RBF are useful for non-linear hyperplane. Polynomial and RBF kernels computes the separation line in the higher dimension. In some of the applications, it is suggested to use a more complex kernel to separate the classifier that are curved or non-linear. This transformation can lead to more accurate classifiers. Regularization parameter in Python scikit-learn is a parameter used to maintain regularization. Here C is the penalty parameter which represents the misclassification or error term. The misclassification or error term tells the SVM optimization how much error is bearable. This is how you can control the trade-off between decision boundary and misclassification term. A smaller value of C creates a small margin hyperplane, and a larger value of C creates a larger margin hyperplane. Another thing is the gamma. A lower value of gamma will loosely fit the training data set, whereas a higher value of gamma will exactly fit the training data set, which causes overfitting. In other words, you can say a low value of gamma considers only nearby points in calculating the separation line, while a value of gamma considers all the data points in the calculation of the separation line. That's what you need to understand about tuning of hyperparameters. Advantages of SVM. SVM classifiers offers good accuracy and perform faster prediction compared to naive-Bayes algorithm. They also use less memory because they use a subset of training points in the decision phase. SVM works well with a clear margin of separation and with high dimensional space. What is the disadvantages of SVM? SVM classifiers offers good accuracy and perform faster prediction compared to naive-Bayes algorithm. They also use less memory because they use a subset of training points in the decision phase. SVM works well with a clear margin of separation and with high dimensional space. That's all. Thanks for watching. Please like, share and subscribe. Thanks a lot.